Assalamualaikum and good day. My name is Rohnazwan bin Rohaili. Today I will be presenting for EMM3316 Fluid Mechanics 1. And the title of my presentation is Understanding Fluid Properties and Their Engineering Applications. In engineering, especially in fluid mechanics and process design, knowing the physical properties of fluid is essential. These properties directly affect how fluid behave, such as how they flow, transfer heat, or mix. They also influence how energy is used and how reliable a system is. In this presentation, I will focus on three major fluid properties, which is viscosity, density, and surface tension. For viscosity is the measure of fluid's resistance to flow. It describes how much fluid resists changing in shape or how neighboring layers of the fluid move relative to each other. It's often thought of as the friction of a fluid. For example, molasses has a much higher viscosity than water. In engineering, viscosity is important to determining how much force is needed to move a fluid through pipes. It also affects processes like spraying, injection, molding, and surface coating. For density, or mass density, is defined as the mass of a fluid per unit volume. The SI unit, kilograms per cubic meter. For example, the density of water is 1000 kg per meter cube. Density can change depending on temperature and pressure. In engineering systems, higher density fluids exert more pressure and need more energy to be transported. Density is also very important in separation processes. For example, when we separate oil from water based on their different densities. And for surface tension is the force that acts at the surface of a liquid caused by cohesive forces between molecules. It's what makes water from droplets or lets small insects walk on water. In engineering, surface tension is important in systems that use droplets or bubbles like in spray emulsion or microfluidic devices, which matters in cleaning, coating, and other fluid delivery system. So for the application in engineering, viscosity in biomedical engineering is used to understand blood flow and fluid dynamics inside the human body. It plays a role in drug delivery, circulation, and designing devices like catheters and artificial organ. Most researchers focus on Newtonian fluid, where viscosity stays constant, but many real fluids like blood are non-Newtonian. So for the density is in petroleum engineering. So density plays a key role in this field. One example is in descending and dewatering, where sand and water are removed from crude oil because they are denser than the hydrocarbons. We also use density to separate different hydrocarbon products like gasoline and diesel, since they each have specific density range. So for the surface tension is mixing and spraying. Surface tension affects how fluids from droplets and bubbles. This is very important in the industrial processes. For example, in gas-liquid mixing system like bubbles columns and aeration tanks. So for the conflicting engineering issues is energy versus flow rate, which is gas-liquid system. In systems like boilers or evaporators, adding bubbles help improve heat transfer because of the increased surface area of turbulence. And the slurry pipelines, solids are suspended in a liquid. To keep the solids from settling, we need to maintain a certain flow velocity. But increasing the flow velocity also increases energy use and pressure drop. To handle these challenges, engineers use several techniques. We use CFD or computational fluid dynamics to simulate and optimize the flow and phase behavior. Finally, we adjust system parameters like flow speed, fluid composition, and pipe layout to balance efficiency and stability. So for the conclusion, understanding fluid properties like viscosity, density, and surface tension is essential for designing and running engineering systems. These properties affect how fluid move, how energy is used, and how system perform. And these engineers must use smart design, good materials, and simulation to find the best balance between performance, efficiency, and safety.